Hi, this is Kishore and welcome back to Kishorelytics. In this video, we are going to do something exciting and that we are going to solve the LeetCode problems. So right, today I will come with two types of the problem. One is all about the medium level, second is all about the odd level problem. So the medium level problem is all about the numbers of the pairs of interchangeable rectangles. So I just come with two types of the solutions. We have discussed right in this video we have discussed two types of. One is all about the brute force and what are the problems we are facing in the brute force, and we are getting to the optimal solutions we have discussed. And the second type of the problem is also a very important problem that is called the trapping the rainwater. That is to be asked in the many top in MNC interview questions. Right. So I don't want to take much time of you guys. Let's dive into it. Yes guys, in this video we are going to dive something exciting, that is we are going to solve the LeetCode problems. We are stepping down into the solving the LeetCode problems. Today we are going to solve the two LeetCode problems. One is the medium level and second is the hard level problem. So first let's discuss about the medium level problem, later we will get into the hard level problems. So the first medium level problem is all about the numbers of the pairs of the interchangeable rectangles. So you are given n rectangles represented by the 0 index 2D array. So the question gives the 2D array rectangles where rectangles of I is equal to width comma height of I. So denotes that the width and height of the ith rectangle. So the question gives us to the 2D array. It consists of the rectangles. It consists of two rectangles. Inside the rectangles, we have the width and the height. So that's all about the questions. So two rectangles I and j, I less than j, are considered to be the interchangeable. So if they have the same width to height ratio, more formally, two rectangles are interchangeable. So if the width divided by height 1, height I is equal to width divided by width j divided by height j. So return the number of the pairs of the interchangeable rectangles in the rectangles. So if you see the questions, we can't able to understand, right? So what does the question gives? The question gives the 2D array. 2D array consists of like this. They will give like this question. In this question, they will give. Consider this is a sample input. Okay, they will give like this. So this is to be considered as a width. So this is to be considered as a height. Okay, fine. So we want to find how many pairs of rectangles are interchangeable. So how we can find numbers of pairs of rectangles are interchangeable. So that's only we want to find interchangeable. So how? Think about it guys. So they are giving in the question itself, if we divide, if width divided by ij is equal to width of j width divided by I. So that's only if we divide width of I, so width I divided by height I, width j divided by height j, height j. Okay, if if this both is equal, this is to be considered as one pair. These rectangles are going to be interchangeable. So for example, if 1 divided by 2 equal to, this is first rectangle, this is width I and height I, this is to be considered as a width j and height j. Okay, let me consider 1 divided by 2 into 1 divided by 2. So if it is 1 divided by 2 is equal to 0.5 is equal to 0.5, right? These two rectangles are interchangeable. So we want to update the count equal to 1. Again, if we consider this one rectangles with I and with j, with height I, and this is going to be considered as the I with j and height j. If I divide this one, like 1 by 2 is equal to 1 by 2 means what is going to be happen? 0.5 is equal to 0.5. So this is to be also considered as an interchangeable. So we want to again update the count to be 2. Likewise, how many pairs of, we want to find how many pairs are interchangeable. That's what only we are going. We want to return the numbers of pairs. We want to return the numbers of pairs of rectangles are interchangeable in the rectangle list. So it is to be considered as a rectangle list. Okay. They will give the question is all about they will give the 2D array. In this 2D array, we want to find how many numbers of pairs of interchangeable rectangles are available. So how to find the pairs of rectangles are interchangeable means, if we divide the width I divided by height j, height I equal to width j. This is a formula, right? This is the formula width. So what happened? Width I divided by height I, it is equal to width j equal to sorry, it is divided by height j. Okay, that's all about this question. So now let's dive into the brute force solutions. We are going to discuss about the two types of the solutions. One is about the brute force solutions, one is all about the optimal solutions. So I just write the brute force solution, the pseudocode, and I just compile the optimal solutions. Later we will discuss about the time complexity and space complexity also in the later. So the brute force solution, what is the brute force solutions when it comes to mind after seeing this question? So as a beginner, I just simply initialize the count. So this is to be given as the output, right? This is to be given as the output. So after that, I just simply pick up the, I just simply find the length of the list. I just simply find the length of the list. So what is the length of the list? The length of the list is equal to 3, right? So I just simply find the length of the list. Okay. After finding the length of the list, I just iterating through this length of the list. So I'm just initiating the pointer called I. So consider I'm just writing here 1, 1,2, 1,2, 1,2. This is a sample input, guys, and this is not available in the question. So after this, I just iterating through the entire array. So I'm just iterating for I. So this is the I. This is to be considered as I. After iterating through the list, I just got the 1,2. So after getting the first rectangle, this is the to be considered as the first rectangle. This is to be considered as a first rectangle. After that, I just want to get the second rectangle. Because why? Because I want to get the second rectangle means I just want to compare with rectangle 1 equal to rectangle 2. Okay, right? That's only in the question all about, right? So I just want to get the second rectangle. So again, I just initializing the again a j pointer. It is I pointer, and this is the j pointer. J pointer is all about the I plus 1. What are in the I that is previous. After the I just want to pick up the second rectangle. That's what in the second rectangle. So this is to be considered as the second rectangle. After getting, now I just got the first rectangle and the second rectangle. This is to be considered the first rectangle. This is to be considered the second rectangle. Now I got the first two rectangles. So after getting two rectangles, I just want to simply divide that into the if it is, I just want to check whether the with I divided by I equal to with j divided by ij. I just want to compare, right? So for that, so if we with I divided by I is equal to with j divided by ij. So I don't want to come into the safer part. I just want to come into the safer part. So I just simply cross multiply this. In mathematics, we can simply cross multiply, right? So what is the cross multiplication? With I into ij is equal to with j into I type. Why I am going to the cross multiplication means in Python, if we consider into the Python, we can get the precision errors, right? So what is mean the precision errors? If we are already discussing the Python crash course itself. If you don't want to watch that video, please make sure to watch the Python crash course. I just taught awesome in the Python crash course. So I just what is the precision error means? If I in one rectangle I just got the, for example, in one rectangle I just got the 3.14159. Okay, in again rectangle 3.14129. So consider I just want to compare to all those things. I just want to compare all those things, so that I just simply multiply. I don't want to get it in the floating integers. I just want to simply get into the integers, floating device. I don't want to get in the precision errors, right? So I just simply multiply those things. So after doing all those, I just getting the first rectangle. I just getting the first rectangle. I just again getting the second rectangle. After getting the first rectangle and the second rectangle, I just simply cross multiply with I divided by ij and equal to I. If it is equal means I just simply increase the count plus equal to 1. So after doing all those things, after iterating through the entire array, I just simply return the count. Okay, guys, I just explained the brute force solutions. Now let's get into the pseudo code of the brute force solutions, right? Pseudo code. So first of all, if you want to iterate, first of all we want to write the solutions. It is a def. I just write the pseudocode in the pseudocode. So just it is a function interchangeable of it getting the rectangles array, rectangles of list. Okay. After getting into the functions, I just want to find the, first of all let me find the let me find the length of the list. This is the first step, right? So n is equal to len of rectangles. After finding the n of the rectangles, I just simply initialize the count equal to 0. After initializing, I just want to simply iterating through the entire array, right? For I in range of n. After getting into the, I just okay, 1 minute, guys. After getting this, I just iterating again. I just want to initialize the second pointer for getting the second rectangle. So what I can do that for j in range of I plus 1 comma n. What is that j means? J is after the first rectangle. I just want to get the second rectangle. That is the j, right? So that's what the j. So after getting the j, I just want to simply getting the first rectangle. W1 comma h1 is equal to rectangles of I. Rectangles of I. And this is the first rectangle. This is the first rectangle. Okay. And again W2 comma h2 is equal to rectangles of j. J is to be considered the second rectangle. First rectangle, second rectangle. That's all. And after getting the two rectangles, now in my eye, I just having the first rectangle. I just having the second rectangle. I just simply implementing the if condition. If W1 star h2 is equal to, why I am just multiplying into the h2 means with 1 divided by h1 is equal to with 2 divided by h2. I just simply cross multiplying. Why I am just doing the cross multiplying means I don't want to handle the precision errors. So I simply cross multiplying. If W1 star h1, where is my pointer? Okay, it is here. Yeah, W2 star h1. If it is equal means I just simply increase the count plus equal to 1. After iterating through the entire array, I just simply, after finishing this, I just simply want to return the count. Now in this count, I just having the pass. How many pass are interchangeable? I just having. Okay, that's all about the brute force solutions. So why the disadvantages we are facing in the brute force solutions? The first problem, there are two problems we are facing, right? The two problems we are facing. The first problem is all about the precision errors. We want to handle the precision errors, right? The second problem is all about the time complexity. If the length of the array is increased, the time complexity also increases. It is increases at the 0 of n square, right? So I just want to reduce this to the O of n, big O of n. I just want to release at minimum n log n also. I just want to release. So the time complexity I just want to facing. I'm just facing these two disadvantages in the brute force solution, right? The first is all about the precision errors. We are going to cross multiplying. I don't want to do that. One is all about the precision errors, and second is all about the time complexity. The two problems we are facing, right? So how we can overcome it? That can be up in the optimal solution. So now get into the optimal solution. So now, yes guys, now let's dive into the optimal solutions. So what is the optimal solutions that comes into the mind? First of all, we want to reduce the precision errors, right? For this precision errors, I just come with an GCD. To handle the precision errors, I just come with a solution called GCD. First of all, we are reduced to numbers. If I consider 3 by 6 is equal to, let me consider the 3 by 6. If we reduce, I just want to simply reduce this into the normal form. Simply reducing, if the 3 by 6 is equal to, it is to be divided as a 1 by 2, right? So if we can consider that normalized form, we can easily get the we can doesn't get the precision errors. So that's what the optimal precision errors, the GCD comes in. We are going to reduce the normalized form. So we are reducing to the normalized form. Normalized form we are reducing. So for handling the second problem we are facing about the time complexity, right? So for the handling the time complexity, I'm just initializing the dictionary. It is called the hashmap. In Python it is called the dictionary. It is called the dictionary. So what I'm going to do that, first of all, let me reduce the GCD. First of all, let me implement the GCD of this rectangle. After initializing the GCD, I just simply see whether this pass. If I consider, first of all, let me find the GCD of the rectangle. Consider. Yes, guys. First of all, let me find the GCD of width, height. Width of first rectangle and the second rectangle. So finding the greatest, what is mean with the GCD? We are finding the greatest common factor. We are finding the greatest common factor. What is mean by the greatest common factor? If we 3, 6 for the 3, 6, what we can multiply? It is to be 1 and 3. So for 6, 1, 2, 3, right? So wait a minute. Yeah. what happened? Yeah, 3. So the greatest common, it is, what is the common? It is 3, right? So the greatest common factor of the first rectangle is 3. So with the help of the GCD, I just simply reducing. I'm just simply reducing the width. So width divided by G, and I'm just height divided by G. I'm just simply dividing both the numbers. I'm just simply divided with the help of the GCD. Just simply dividing the width and just simply dividing the height. So we can get the normalized reduced form, right? So here we can get the normalized form. So we handled the first uh, consequences. Okay, we handle the first disadvantage. We are making it as an advantage. We are reduced. So after making this, I'm just seeing simply initialize into the dictionary, right? It is a dictionary. If I see in this pair again, if 1 comma 2 is already in main, means I just simply increase the count to 1. If it is already not, means if it is already not in the dictionary, means I just simply initialize the 1 comma 2. It is to be considered as 0. I'm just again initializing the pass. This is to be considered as a count. Count is equal to 0. I can just if I see, if I 1 comma 2, if I see the 1 comma 2 before, no, I just see means 1 comma 2. I just simply placed it the 1 comma 2 in my dictionary and just simply initialize the 0. If I again see the 1 comma 2, again my loop checks. If I have I seen the 1 comma 2 before, yes, I just seen the 1 comma 2 before. I just simply increment the 1 to 1 and pass. There we can make the 1 pass, right? So the pass to be increased as 1. So again, if I 1 comma 2 comes means 1 comma 2. If it is comes means 1 comma 2. If I already see the 1 comma 2, yes, I just already see the 1 comma 2 in my dictionary. I just simply increment the count to 2, and again here the pass to be increment plus equal to 1. So that's all about the optimal solutions. So the two problems we are facing. The first problem is all about the precision errors. We handle the precision errors through the GCD. So the second type of error we can handle the time complexity. So we can handle with the hashmaps, that is called the dictionary. So for this dictionary, I'm just using the default text. So now let me get into the editor, LeetCode, for solving this problem. So yes, now we are getting into the LeetCode. So I'm just simply from math module, I'm just simply import the GCD. From collections module, I'm just simply import the default dict. So what is meant by the default dict means default dict is nothing but, make note of it guys, it's a very important library. It automatically initialize the key to the value. That's the main important to the default dict. So if it is 1 comma 2, it is to be considered as 0. It automatically initializes. We don't want to initialize again. We don't want to initialize the hard coded. It automatically initializes the using the default dict. It automatically initializes the key values. So if as for something what I can go told, if I search with the key, means if the key is not in the my dictionary, we can get the error, right? So I don't want to handle the error. So I don't want to handle this error. So I just simply go with a different dictionary. I just already in the default dict. So I just simply from it is in the collections model. I'm just simply importing that from collections import default dict. So this is to be given as the LeetCode template. So first of all, let me initialize the default dict. So how to initialize the default dict means, if you are just simply initialize the count. It is a variable. I just want to, in a normal dictionary, we want to initialize like this. So if we want to initialize the default dictionary means, if default dict using the default dict library of and initialize this into int. I'm just storing with the integer value, right? If you are going to store the float value means you can initialize with the float. So likewise you are going to initialize. So ratio count is equal to default dict of int. So after doing this, I just want to simply count, right? Pairs is equal to 0. Why I'm just initialize the pairs is equal to 0 means I just want to simply count the number of pairs. I just simply want to return numbers of the pairs of the interchangeable rectangles in the rectangles. So I just simply initialize the pairs. So after getting that, I just simply iterating through the entire list. See, I'm just simply iterating to the entire list 1 comma 2. I'm just taking the sample input 1 comma 2, 1 comma 2. I just simply and iterating through the entire list for w comma h. I'm just simply iterating to the entire list. After getting into the entire list, I just simply get the GCD. First of all, getting into the loop. After getting, let me take a new sheet. So here I just want to write 1 comma 2, 1 comma 2, 1 comma 2. So let me keep it as 3 comma 6, 4 comma 2, 5 comma 6. Let me take it as 3 comma 6. Now in my hand, for iterating through the w comma h, in the rectangle list, I just simply got the 3 comma 6. right? After getting the 3,6, I just want to simply find the GCD of these two. After finding the GCD means GCD of 3,6. Now I just want to find the GCD. So what is the GCD? GCD of 3,6 is 3, right? So with the help of the GCD, I just simply get into the normal form. And now I got the GCD. And now I just want to reduce the normalized form. Reduce to the how we can reduce the normalized with the help of the GCD. I just simply divided this GCD with and height. So what I'm gonna do that W G gonna G and H gonna divided by G. I just divide both width and height with the help of GCD. Now it can be happened as 1, 2. Now it is to be reduced. We just want like that only, right? We are going to reduce the normalized, reduce to the normalized form. So that one the G is equal to GCD of W, H. After now we are finished this process. So after getting into the process, now I'm just saying initially pass plus equal to ratio count of normal. What is the normal? This is the 1, 2. Here I just simply pass plus equal to in the default dictionary. I just initializing pair. If I see this pair, I just want to simply increment the count. If I didn't see the pass, I just simply initialize that value to the dictionary. How it can be happen? So after finishing the reducing to the normalized form, now this is how the looks like, how the dictionary, how the rectangles looks like. So first let me pick up the rectangle one. If the rectangle have 1, 2 is already in the dictionary, have I already seen this dictionary in my if seen this rectangle in my dictionary? If I don't see this dictionary, I just simply it is 0. I just simply increment the pass plus equal to 0 and the ratio count of 1, 2 becomes 1. So I just simply get in the second dictionary, second rectangles. If I already seen the 1, 2 in my dictionary, yes, I just seen the 1, 2 in my dictionary. So I just simply increment the pass plus equal to 1 and the ratio count of default dictionary becomes 2. Right? Likewise, have I already seen the pass 1, 2 before? Yes, I just seen the 1, before 1. So I just simply incrementing. It is to be become as a 3. So 0, 1, 2. So likewise, pass to be increment to be 1 and the ratio of the count of the dictionary becomes 3. Likewise, it is going to be happen. After doing this entire process, I just simply written the count. This is to be considered as the pass, right? This is to be given the give the output. So that's what the happens. Okay. So now I'm just simply press the control plus enter to submit the code. Yes, it is accepted. It is works with the better solutions, right? So we just completed the numbers of pairs of the rectangles. So let's give the quick recap to the numbers of the pairs of the rectangles. So yeah, this is to be considered as a first page. So they give the rectangles. It is they give the 2D list, and this is to be considered as the rectangles. And now we want to find out how many pairs of the rectangles are interchanged. So for my brute force solution is that I just simply get the first rectangle, I just simply get the second rectangle. After dividing these two rectangles, I just simply count it. So likewise, I'm just using the brute force solutions. So for getting, I'm just using the two problems. First is the precision errors, and second is the time complexity. So after doing all those things, I'm just getting with them GCD. I just want to find that GCD, and I'm just using the hashmaps. That is called the dictionary. So these are the solutions we have discussed, right? So now let's dive into the odd level problem that is called the trapping the rainwater. Now let's dive into it. Yes guys, now let's dive into the odd level problem. So the problem is all about the trapping the rainwater. So let me read the questions. Given the n non-negative integers representing an elevation map where the width of the each bus is 1 and compute the how much water can be trapped in after the raining. Okay, we want to find how many numbers of the units of the water to be trapped on the bars. So that's only we want to find. So now let me get into my this solutions. So we want to find how many units of the water. The main agenda is all about the how many units of the water. Units of the water we are going to store inside this bar. So for this bar is going to be stored as a 1 unit. For this bar, it is going to be stored as a 1 unit. Sorry, it is going to be stored as a 2 unit because here it is 1 and here it is also 2. Right? It is going to be stored as a 2 unit. For this bar, it is going to be stored as a 1 unit. So for this, I'm just came with a formula. What is my formula? The water can be stored depends upon only the minimum of the bars. Right? I'm just simply implementing I just simply noting the water can be stored depends upon only the minimum numbers of the bars the waters can be stored, right? If the water can be stored like depends upon the highest bar means the water may be spills down, right? So that's only we want to find in this question. So they are giving the non-independent integers. We want to find how many units of the water can be stored. So for this, I just came with an two types of the solution, that is called about the brute force solutions and is all about the optimal solutions. So now let's discuss about the brute force solutions, right? So what is meant by the brute force solutions? What comes in the mind as a beginner, as my beginner, what comes in the mind? First of all, let me find the length of the list. So first of all, let me find the length of the list. After finding the length of the list, I am just simply initializing the water. What is the water? How many units of the water can be stored in the water units? That is this is to be given as a result. Okay, let me initialize it. So I just simply iterating through the entire list. Iterating to the entire list. First of all, let me find the initialize the two variables called the left max and the right max. So first of all, let me find the here what are the before I, if anything is max means I just want to simply find the max. I just store in the left max variable. After I, what are the things that is going to be I? What are going to things that is going to be maximum of the I? So that is going to store in the right max. After finding those left max and the right max, I just simply finding the minimum of the left max and the right max. Left max and the right max. I just simply minus with the height of the I, height of the j. So what is mean by height of n? The total length of the units. If it is 1 unit means I just want to simply minus with 1. So that's what the height of I. So let me write the pseudo code. I think the brute force solutions will be efficiently like let me find the length of the list. First of all, let me find the length of the list. After finding the length of the list, I just simply initializing the water 2 equal to 0. After finding the water is equal to 0, I just simply iterating through the end of the entire array for I in range of n. I just simply iterating. After iterating, I just simply initializing the left max. What are the left max means? Max, I just want to find max of height of, this is to be length, this is to be considered as array, right? Array of, what is to be, what are the things that are going to be before I? Before I just want to find before I, what are the things that is going to be greater I? So that is only stored in the left max. After finding those things, I just want to simply find the right max. What are things that is going to be after I, which is the what are things are greater than I? So that is only stored in the I. Max of height of I plus 1 is 2. Likewise, you want to find. So here I just want to simply find the I only. After I just want to find. After doing all those things, I just simply plus with water plus equal to, this is to be stored as the result, right? I just want to simply find the minimum. Why I just simply finding the minimum means, as I already discussed, the water going to be stored depends only on the minimum bar, right? So the water going to be stored minimum on the minimum bar. How it can be stored? Minimum of left max. We want to find the left max and the right max. After doing all those things, I just simply minus with height of I. Okay, why I just simply minus with height of I means here there is 2, we can get with the 2, we can store the 2 units of the water in this bar. Here I just want to simply store with the 1 unit of the water. So I just simply minus with height of I. So that's what in this formula looks like. I'm just simply implementing the formula. What are the things we are going to summation of? What are the things we are going to find the minimum of the bars. We are main focus is only on the minimum of the bars. So what are the things that are going to be having the left max? The main formula. This is the main formula, guys. This is to be stored in the used in the optimal solutions also. Just note it down. So what are the things that is going to be stored in the left max, and we want to find the minimum of the bars, right? What are the things that is going to be stored in the right max, and we are minusing the solutions. So that's what the problem. That's what the formula of this trapping the inverter, right? So now we have discussed about the brute force solutions. Now let's dive into the optimal solutions. Now let's discuss about the optimal solutions. So what are the things, what are the problems we are facing? If the length of the array is increases means we can face the time complexity, and we can face the space complexity also. So for that, here also I'm just initially using the 2-pointer approach. So the solution is that the optimal solution is all about the 2-pointer approach. The solution is all about the 2-point approach. What is it, what we can discuss in the 2-point approach? We can simply initialize the left pointer as well as the right pointer. So let me come with a solution example 0 1 0 2 1 0 1 3 2 1 2 1. Let me come with a solution. So first of all, let me initialize the left pointer and let me initialize the right pointer. This is to be considered as the left and this is to be considered as the right. So after initializing, this is to be left is equal to 0, right? Right equal to len of n minus 1. This is to be considered the left, this is to be considered. No, simply I'm just initializing. So again here also I'm just simply initializing the left max. The main formula is all about the we are going to sum of we are going to find the min of left max and right max minus the height of I. That's what we are discussing the brute force solutions, right? So that's what we are discussing the brute force solutions. This is the important formula we have discussed. So after initializing, I'm just simply initializing the left max is equal to 0 and the right max simply equal to 0. After I'm just simply the result. This is to be stored as the result. Water, how many units of the water simply is to be 0. So what I'm going to do that I'm just simply pick up the I'm just simply checking the loop while the left pointer is less than the right pointer. If it is less than means we are focusing on the minimum part only, right? Minimum of the bars. So I just simply get into the array, simply getting into the loop. After getting into the loop, I'm just simply checking whether this height of left is nothing but the 0. If height of left is less than the height of right, if it is true means if it is the left max, we are checking the left max and the right max. If it is true means I'm just simply checking another condition. If height of left, I'm just again checking 0 greater than the left max. The left max we are initialized 0, right? So 0. So if I am again checking this condition, totally I'm just checking whether the main focus is on only on the minimum bus. So I'm just checking the 3 conditions. What are the 3 conditions we are checking? So we are checking about the left while the left less than the right. After getting into the loop, I just checking the second condition. Second condition is all about the I'm just checking left max is less than the right max. I'm just checking. Okay, if it is less than means I'm just again checking whether the height of left is already greater than if height of left is greater than the left max. What we have initialized in the left max. If it is greater than means if it is height of left, this value is greater than means yes, this value whether the left max is greater or the right left max is greater or the left point is greater. The left point is greater, right? And simply reinitialize the left max is equal to 1. So that's what I'm going to store. If it is yes, and the left max is greater, so I'm just simply getting down into the water plus equal to I just simply find minusing the left max. What are the things? I just find the left max minus the height of the array. What is the height of the array? Simply this is I1, right? So I'm just simply minusing. So if it is a 4 minus 2, it is 2. That is going to be stored in the water. So that's what the optimal solutions comes here, right? Have you understood, guys? So if you have any doubts, please let me know in the comment below. I'm just happy to share all those comments. So I'm just simply checking 3 conditions. First of all, let me check in the left less than right. I'm just simply checking the height of left and simply with the height of right. After getting those things, I'm just simply checking the another condition. If the height of left is greater than left max, we are initialized, right? That's what we are checking. Sorry. So after doing all those things, I'm just simply increment the pointer, left pointer. I'm just simply increment the left pointer to 1. Likewise, we are going to do in the right pointer. I'm just simply checking the height of right is greater than the height of left right max. I'm just simply checking. If it is greater than means, yes, I just simply reinitialize the right max. After doing, if it is less than means, I just simply water plus equal to. Likewise, we are doing and simply reducing the right minus equal to 1. So that's what we have discussed in the optimal solutions, right? So now let's get into the implementation of the code. Yes. So this is the template for the code solutions. So first of all, let me find the length of the list. So n is equal to length of the list. Let me reduce this. Okay, fine. After doing all those things, I'm just simply initializing the left pointer and the right pointer is equal to 0 and the n minus 1. So I'm just simply initializing the left max and the right max. So, okay, fine. So I'm just checking with the initialize the result pointer. Result variable, it is the water I equal to be 0. I'm just simply equal to reducing. So while I'm just simply checking left less than the right. I'm just checking whether the left pointer is less than the right pointer. Right? I'm just checking whether the left pointer. I'm just checking if it is true means I'm just getting into the second condition. I'm just checking whether the height of left whether the height of left is wait a minute. Whether the height of left is greater than the height of right. I'm just checking. So if it is, and the main focus is on only on the minimum pass, right? So only I am checking the left less than. So if it is also true means I'm just checking the another condition. If height of left is greater than the left max, we have initialized. Now it is 0. If it is 0 means, if it is greater than means I just simply reinitialize the left max. So if it is if this condition is fails means I just simply left max minus height of max, that is can give me summation of water. We have discussed, right? So now if it is left max is water plus equal to 4 minus 2. Now it looks like this. Likewise it looks like. So after doing all those things, I'm just simply incrementing the left pointer to be 1. So likewise we are going to do in the right pointer else part. This is to be considered the else part. If the height of right greater than the right max, we are checking. If the right of max is greater than means, if the height of right is greater than means, I'm just simply reinitializing the right max. Right max is equal to height of right. So if it is if this condition fails means, I just simply reinitialize the likewise this condition, this water is equal to 4 minus 2. Likewise we are height of right, what are the height of the array we are going to minus, and we are going to minus that what are the things that is in the right max we are going to minus. So after I'm just simply reducing the pointer right minus equal to 1. So after doing all those things, I'm just simply returning the water, right? So let me with the sample test cases whether it takes pausing or not. Okay, let me take it down. Yes, the sample test cases are working fine. So now let's get into the background test cases. I think it works well. Yeah, it's worked fine. Yes, right. We are getting the 100%. Right. So that's all about this video. I think I explained the two solutions, two problems very well. So if you understand this video, please make sure to subscribe to the Kishorelytics channel. If you find this video useful, please make sure to share with your friends. So that's all. Tata. Bye bye. This is Kishore signing up from the Kishorelytics channel. Tata. Bye bye.